A fresh neural network is embarrassingly dumb. Its internal knobs, called weights, are set to random numbers. Show it a photo of a cat and it guesses blindly, maybe dog, maybe airplane. Yet from this random noise, given the right training, something remarkably capable will emerge. How? A neural network is layers of tiny units loosely inspired by brain cells. Each takes numbers in, multiplies them by its weights, and passes a signal on. No single unit understands anything, but stacked in layers, they can represent breathtakingly complex patterns if the weights are set just right. Training begins by measuring failure. The network makes a guess, and a formula called the loss function scores how far off it was. A confident wrong answer scores terribly. This single number, the error, becomes the compass that guides everything that follows. Here is the trick that makes it all work. The network runs its error backward through every layer, calculating how much each individual weight contributed to the mistake. This is backpropagation. Suddenly, a system with millions of knobs knows exactly which ones to blame and by how much. With blame assigned, each weight nudges slightly in the direction that reduces the error. Picture a ball rolling down a hill toward the lowest valley. This is gradient descent. Take a tiny step downhill, again and again, and the error slowly, steadily shrinks. One example barely moves the needle, so the network sees millions of examples over and over, nudging its weights a little each time. Slowly, patterns crystallize, edges become shapes, shapes become faces. Learning is not magic, it is relentless, tiny correction at enormous scale. Backpropagation is not new. The core idea was understood in the 1970s and popularized in the 1980s. But it needed two things that arrived much later: enormous datasets and fast parallel hardware. An old algorithm sat waiting decades for the world to finally catch up to it. There is a danger. A network can memorize its training examples instead of truly learning, acing practice questions, but failing the real test. This is overfitting. Much of the craft of machine learning is forcing models to generalize, to find the rule rather than memorize the answers. So how does random noise become intelligence? Through one loop repeated at colossal scale: guess, measure the error, push the blame backward, nudge downhill. Every image generator and chatbot you use learned this way, not by being programmed, but by being corrected billions of times over.